20 tons.
Sure.
And the booster will work
has, made leaps forward
Yes.
in our exploration, our passion, and our renewed interest
Yes.
in the moon.
As mentioned by our guest from Pakistan, so their CubeSat will have a very powerful function to take photos on the lunar orbit.
Yeah.
So I believe that it is very beautiful, that's the photos of moon, and also very, very helpful for us. Although, it is important for us to enjoy the far side, the sightseeing on the far side of the moon. But with the orbiters, we can do this. And even today, for instance, the US has a probe called the Lunar Reconnaissance Orbiter. It can even take the pictures of the trail of the rovers on the lunar surface.
So thinking about the long-term goal, Professor Yang, I still want to mention the crewed missions to the moon, because we understand that now we are working towards that goal by 2030, and the U.S. has its Artemis program going on at the same time.
Yes, you know that Miss Wang Yaping, the first space teacher of China, also the first female to enter the China space station, friends of we both, and she has expressed many times to major media of China, she hopes to walk on the moon in the future. So first, I press my best wish to her to fulfill this dream, and also I should emphasize this is another millennium dream for we Chinese. Yang Liwei has already fulfilled the first millennium dream of the Chinese people, and I believe that walking on the moon will be the second one.
Yeah.
So in the future, as you mentioned, we will have the plan to be scheduled before 2030, before the end of 2030, to have our first crewed mission to the lunar surface. But still, we must face, honestly speaking, many challenges during this process. First, we must have a more powerful launch vehicle, even much more powerful than this Long March 5 rocket.
Right. Earlier on, you mentioned the heavier payload for a crewed mission to the moon. Why is it so much heavier than an unmanned mission? Is it because it has to bring with it the life-supporting materials like water, food, for example, to really keep our astronauts alive and functioning well on the moon?
You know that we can have a comparison between the Shenzhou spaceship and the future manned spaceship to the moon. You see that the total mass of our Shenzhou spaceship is more than 8 tons. But you know the difference between Shenzhou spaceship and the spaceship to the moon is that for the spaceship to the moon, it must have much greater capability to change its velocity comparing with the Shenzhou spaceships. So that is reason why our Mengzhou, the next generation spaceship, if it goes to the moon, it will have a very huge fuel tank and have so much propellant. You know that the moon is a big celestial body, although it is much smaller than the moon, than the Earth. So when approaching the moon, we must deaccelerate or brake to conduct the lunar orbit insertion. And also, we need to go back to the Earth. All these procedures need a lot of propellant. So that is the reason why the Mengzhou spaceship is more than 26 tons. So you can see it's even only not include the lander. Even the spaceship itself is 3 times heavier than our Chang'e 6 probe. So that is reason why we need another much more powerful rocket, actually speaking, Long March 10 for this process.
It's heavier because it requires much more fuel to power the mission.
Yeah. So still the second stage is burning. After it is burned off, the probe, the combination of the second stage and our Chang'e 6 will enter the translunar orbit.
Right.
Great. So it's already shut down, as I mentioned.
Already shut down.
Yeah. So the next critical step will be the separation between the rocket and the probe.
Right. And after that, we'll be awaiting the solar panel to open up.
Yeah. So this is viewed by the camera mounted on the second stage.
Well, Professor Yang, I know you are really a professional photographer as well, taking pictures of the moon. What do you fantasize when you look at the moon from Earth?
Well, you know that with the telescope, we can get more details of the lunar surface. I enjoy this, and also many of my foreign friends like it and endorse me on the social media. And also, you know that for a system designer on spacecraft, we must be very familiar with the optical systems. So this is how I can master the necessary skills for study the optical systems. So we can see that on the right, top right is a 3D animation based, as I mentioned, driven by the real data. So still at this moment, we can see the dashed lines is the communication links between the ground station. Okay, beautiful.
And that was the separation
so
of
now
the rocket
you can see the video
and the
is the rear part of the Chang'e 6. Actually speaking, is the orbiter. So we can see the cylindrical part of the probe is the biggest part is the orbiter.
So this certainly marks another important step in this mission. That's the separation of the rocket.
Yes.
And
so
the
this is also another critical step, and then will be the unfolding of the solar panels, both on the orbiter and on the lander, because they will fly independently several days later. So we need the unfolding of the two pairs of solar panels.
And until these two sets of solar panels are opened up, that will mark the success of the launch mission.
Exactly. Moreover, we should also evaluate the accuracy of its initial orbit, because you know that only it is accurate enough we can have the possibility to conduct the successive procedures.
And I also want to talk about China's space station, the Tiangong. What kind of international cooperation is being showcased on the CSS?
I believe that our Tiangong space station is a very ideal place to conduct international cooperation. So today we already have the joint experiments with other countries. And next step, we've already talked many times, will be the visiting of the foreign astronaut to our Tiangong space station. So
you know what, Professor Yang, when I see the scientists, engineers taking out their glasses, it means that they are really relieved to see how well the mission is progressing.
Yes, quite right.
And finally some smiles from these scientists there.
Okay, we just heard his voice that, as I mentioned, the orbital parameters has already been acquired. So, as I mentioned, the accuracy of the orbital parameters is also very critical for our mission.
Sure. Has the spacecraft established communications with the Magpie Bridge 2 at this moment?
No. At this moment, it's still too far from the Magpie Bridge 2. So at this moment, it still has the communication link between the Tianlian data relay satellite or with the space tracking ships, such as Yuanwang series tracking ships on the Pacific Ocean. They are already in SMILE, so that means that the most risky part has already passed for the launch.
And they start talking and having some small chat over there.
Yeah.
It's a rewarding moment for the scientists.
Yeah. So I believe that we can see the big red screen soon.
Yeah.
It's our tradition.
Yeah, it is. It really is something that we're all looking forward to.
Yeah. Now you can see it's already more than half an hour now. So that is a very important feature for the launch of the Long March 5 or the Long March 3A series, because it needs a coaster phase that lasts very long.
And now let's hear some more insights from Mark McCorin, former senior advisor for science and exploration at the European Space Agency in the Netherlands. Thank you so much for joining us on our program. Now, as we are both watching for, as we're both waiting for that big moment, the announcement of the success of the launch mission, what aspects of Chang'e 6 lunar mission are you most looking forward to?
Well, as a scientist, you know, it's an amazing thing to be able to go to the far side of the moon and bring samples back. It's very different from the near side of the moon, the piece of the moon we see all the time because of the way the moon is locked to the rotation of the Earth. It also will hopefully bring us some idea about the way that the moon was struck by large impactors, by asteroids. Early in the solar system history, billions of years ago, Was that something that happened very quickly in one big bunch of impacts, or was that something that happened slowly? And by returning samples from that particular location, the South Pole Aitken Basin, we should actually be able to learn much more about the history of our solar system that way. So that's really exciting. But let me also say, congratulations, of course, to getting to this point now. Half an hour into the mission, it seems to be going extremely well.
And as you mentioned, it really is a very important mission for us to understand the formation, the evolution of the moon over a span of billions of years. And China, as we know, is also carrying international payload in this mission. It's been advocating international cooperation in space for a long time. What do you make of the cooperation between China and Europe, Mark?
Well, I think it's a good thing. I've been talking to some of my colleagues this morning, ESA colleagues who are out there in China at the launch, and hopefully I'll chat to them a little bit later on, and hopefully they will have seen that very, very beautifully as we did on the live stream. But bringing those instruments on board to do science, of course, is the main goal of this kind of cooperation, is to share the scientific knowledge. And this is something where, of course, we collaborate internationally. We collaborate with the United States, we collaborate with Russia, we collaborate with Japan, and we collaborate with China. We also have a mission which should be launched in the next year or so called SMILE, which is a collaboration between China and ESA, where that mission will be investigating the magnetic field of the Earth. And that's an important aspect which is linked to so-called space weather, where the impact of the sun on the Earth's atmosphere is something we want to study in more detail. So we just saw the launch contract for that was signed last week. That will be a European launcher with a European-Chinese payload, and what we just saw today is European parts on a Chinese-led mission to the moon. So I think that this scientific collaboration is, of course, very important. We should always keep in mind that space is a very political environment, of course, and there are all sorts of geopolitical issues in the background here. But as a scientist, I'm very happy to see this collaboration go forward.
Mark, let me also ask you this. I could see Chinese calligraphy hanging on the wall, and I'm pretty sure that you're familiar with the Chinese culture as well. And you must also know that the Chang'e is named after this legendary Chinese moon goddess. Do you also share this dream of lunar exploration, this passion, and of course renewed ambition to explore the moon?
I think it's something, of course, that's fascinated me throughout my life. I'm old enough that I was around when the Apollo missions went to the moon, and I've worked with many of the Apollo astronauts. I've been on tour with Buzz Aldrin, for example, who was on that very first mission with Neil Armstrong to the surface of the moon. And to see that come back now in recent years, of course, there is an element partly, again, of this geopolitical aspect, whereas it was the Soviet Union and the United States before. Now you have a much broader array of players in this game. And there's also this question about this exploitation that your guest there spoke about a bit earlier on, which was that exploration is driving the science, but the possibility of looking at the moon as a resource is another thing. I'm a little bit skeptical about making it a fully commercial thing. I'm not sure how that would work. And we do need to think about how we protect the resources as well, that it shouldn't be a free-for-all, that everybody can go and just get rich. The same applies to Mars. We don't know if there's life on Mars yet. Should we be going there with human beings until we've investigated it properly scientifically? So I think it's a very interesting time. I mean, if I'm right, as you said, the calligraphy behind me is the constellation of Orion, Li Hu Zhuo, if I remember correctly from one of my trips to China. And so I'm also very interested in looking well beyond our own solar system. So I've studied the constellation of Orion for many years in my career, and those dreams are definitely real, and that inspiration that space can bring, and then the collaboration that also encourages, I think, is something we need to reflect back to Earth, collaborating to solve some of the challenges that were addressed earlier in your program, for example, nuclear fusion and how we solve the energy crisis. That we're only going to survive on this planet by international collaboration, and we're not going to go and live on other planets very soon. So I think that's the important strand here, international collaboration for helping this planet. And lunar exploration is an exemplar for that.
Of course, we are seeing competition at different degree, but it doesn't have to be that way. I mean, the discovery, the learning of the moon is certainly bringing benefits to all of humanity. Thank you so much, Mark, for sharing with us your insights. While the Chang'e 6 will carry equipment from France, Sweden, Italy, and Pakistan, it's part of China's international cooperation in space. A French instrument mounted on the lander will study the origin and dynamics of the lunar exosphere. CGTN's Natalie Carney talked to Pierre-Yves Meslin, a planetary scientist whose team invented the instrument.
For years, planetary scientist Pierre-Yves has been working on instruments destined for Mars. But the launch of China's Chang'e 6 spacecraft now puts him at the cutting edge of moon exploration. His invention, the detection of outgassing radon, or DORN, is set to become the first ever French instrument to be deployed to the surface of the moon.
The objective of the DORN experiment is to study both the origin and the dynamics of the lunar atmosphere, but also to study the physical and thermal properties of the lunar soil where those gases are produced.
To do this, DORN will measure the radioactive gas radon, which is produced in lunar rocks and when emitted migrates to colder areas of the lunar environment.
If we understand better the migration of radon, we will be able to better understand also the migration of other volatile species, like for instance water, that can migrate to the cold polar regions and then form ices. That is a prime interest for the future Chang'e 7, Chang'e 8 missions and or emissions for other international agencies.
Romain Maton is the mechanical architect of the DORN.
So here we have the 8 detectors which are shining. The radon is going to be captured by the detectors, 2 detectors forming a telescope. The front one will see the alpha particles coming from the radon, and the other one will be here to discriminate any other events which will be seen by the instrument.
The project team says time was the biggest challenge when it came to the DORN's development.
The project started early 2020, so it was right before COVID time, and we delivered last summer. So overall it was 3.5 years of development, which is something that is super short for us. So having an instrument we develop and that is going to the far side of the moon, it's really exciting for us. We are going to be part of a mission that has a really technological fate. So it's a great honor to be part of it.
More than 20 French engineers worked closely with Chinese colleagues at China's Institute of Geology and Geophysics and the Chinese University of Geoscience in Beijing to make the project happen.
This is the first time that France and China are collaborating in the field of solar system exploration. First, they helped us interacting with the engineers from the spacecraft team at CAST. They also helped us negotiate the spacecraft resources that we needed for our instrument. And they also helped us a lot after we delivered the instrument to China last August. They helped us mount the instrument onto the spacecraft. I think we have established a relationship of trust and also friendship between the two sides.
Pierre-Yves is now in China for the launch of the spacecraft and will stay there for a month to monitor the DORN during its time on the far side of the moon. He'll collect its data and continue harnessing the benefits of international collaboration in discovering the wide, vast unknowns of outer space. Natalie Carney for CGTN, Toulouse, France.
Well, international cooperation is certainly a highlight of this mission, and our colleague Mark, right there, he was talking about turning this idea from exploration of the moon to exploitation of the moon. And you rightly pointed out that really we are facing this first mover advantage. For example, whoever gets there first will have a say on how to explore the moon and maybe perhaps making rules for the exploration of the planet.
To have a smooth cooperation with other countries, we do respect the considerations of other countries. For instance, you know that the landing site site of the Apollo missions are the legacy not only of the United States, but recognize it as the legacy of the whole human being. So we will protect that. Of course, we will do not land in just land in the land side of Tranquility Base, because we have the footprint of Neil Armstrong and Buzz Aldrin there. So we should protect that. It is a history of the human being, not only the United States. So we will protect that. But you know that the moon, the resources are the resources of all human beings. So it is the right moment, because you know that the transportation between the Earth and the moon is already very practical. So it is the right moment for Earth to utilize the resources of the moon. So to this extent, it is the exploitation of the moon.
Right, and we are now almost
So-
50 minutes into this mission, a little over than 50 minutes into the mission.
So the next important step, you know that at this moment is the Chang'e probe is orbiting the Earth in a shadow area.
Right.
So when it meets the sunshine, it will unfolding its solar panels. You know that we've already mentioned it is a very complex mission. It has 3 pairs of solar panels.
Located on the
orbiter,
the
returner,
lander.
and the lander.
Right,
Yes,
and the
exactly.
returner as well.
So, but before the just in this stage, we will unfold 2 pairs of them: the solar panels on board the orbiter and the one in the lander.
Lander.
Yes. Because this moment they are a combination of 4 spacecrafts, but when it already entered the circumlunar.
The lander will be in one part, and the
returner
returner
and the
the
orbiter will
orbiter.
the other part. So
Right.
the one combination becomes 2 combinations. The unfolding of solar panels means that we can get a continuous power supply from the sun.
Right. And during these 53 days of the Chang'e 6 mission, our scientists on Earth, on the ground, will also be keeping precise communication
Yes.
with our probe.
Actually speaking, when it is in the lunar orbit, we can utilize our ground stations. But when it is on the surface of the far side of the moon, we can only depend on our Qiao data relay satellites. And you see that, as you mentioned, you know that in the 4th phase of our lunar exploration program, actually speaking, in the Chang'e 8 mission, we will demonstrate the right technologies to utilize the resources on the lunar surface. So the on-site resource utilization is already on its way. So we are preparing for the exploration of the lunar resources.
And as we mentioned just now, Professor Yang, the sampling procedure will involve 2 parts. One is drilling, and the other part is scooping. The solar
Exactly.
panels are being unfolded
Yeah.
on the orbiter.
Yeah.
That's right, and that is.
So this is the first step.
First
This is shown by the, as I mentioned, the real telemetry data received from the vehicle itself. So although it's only a 3D animation, but it can represent the real status of the spacecraft.
Now, can we say at this stage that the probe, the spacecraft, will be on its own?
Actually speaking, it's already on its own during the separation between the rocket and itself. But still, you know that at that moment, because it's in the shadow area of the Earth, so it can only use the electricity in the storage batteries inside the probe.
Right.
So at this moment, with the unfolding of the solar panels, it can have, as I mentioned, a continuous power supply with solar energy.
What is the difference of the lunar soil retrieved from drilling and the scooping procedures?
Yes, good question. You know that when we get the samples by drilling, we can have a better understanding of the evolution of the moon, because many information were under the ground, under the surface of the moon. So if we can get more deeper under the surface, this can get many information. And for those on the surface, you know that for billions of years, for more than 4 billions of years, the influence of the sun and the surrounding environment also is very important for us to study. So you know that the regolith, the rock on the surface of the moon, already